today we're going to be talking about distance applications. And if you remember, before when you work with distance, the formula for distance is distance equals rate times time. In the problems we're going to do today, it's going to work better if we solve this formula. And actually, I wrote the wrong thing up here. We want to solve it for time, and time is distance divided by rate. In other words, we want to take this little equation and solve it for time. So we're going to divide both sides by r and get time equals to distance divided by rate. We're doing that because the problems we're going to be working on today with distance are going to all have their times related some way to each other, and it makes it easier to set them up if we'll use this as our formula. So this is what we're going to use. Time is distance divided by rate. And we're going to be looking at three different types of distance problems that are going to have relationships with their time. In some of the problems, you'll have time 1 plus time 2 equals to a total time. That's one thing we'll be doing. Another one we'll be talking about the difference of two times. Time 1 minus time 2 equal to some difference in time. So we'll have a difference. And then the third one is that time 1 equals to time 2. So in every distance problem that we look at today, we're going to be trying to decide whether the times add up to a total time, whether they differ by some time, or whether the two times are equal. That will help us in solving our problems if we can pick out those things. So what you might do when you're doing your own problems is look for those things and circle the words in the problems that tell you which of these categories things will fit in. As we solve our problems today, we're going to set up a chart, and in our chart we're going to have distance, rate, and time, which will be our distance divided by our rate. So let's look at our first problem. The president of a company traveled 1,800 miles by jet and 300 miles on a prop plane. The rate of the jet was 4 times the rate of the prop plane. The entire trip took a total of 5 hours. Find the rate of the jet plane. Now, what we're going to do when we try to set this up is we're going to forget about what I said about the times for just a minute. So ignore the time stuff for just a minute. We're going to try to fill things in our chart, try to fill in our distance, fill in our rate, and then get our time by doing distance divided by rate. Then once we get all those things filled in, then we're going to go back and decide which of these three categories our time stuff fits into. So when you look at this first problem, the first thing we want to do is to pick out what are the two different kinds of travel they're talking about. So we want to pick out those two things and write those down. So what are the two different kinds of traveling? This person is traveling by what? By jet and also by prop plane. I'm just going to put plane. How far does he go by jet? What will we fill in for our distance for the jet? 1,800 miles. And how far does he go on the plane? 300 miles. And then we have to see how fast they're going. Now, it doesn't tell you how fast they're going, but it tells you that the rate of the jet was 4 times the rate of the prop plane. So what can we do with that? The rate of the jet is 4 times the rate of the plane. So one of those I want to be x. Which one would you let be x? The plane. And the other one is 4 times the rate, so it would be 4x. Since it says times, not more or faster, it says times, you multiply by 4. Now, when you get over here to the time column, we're just going to use what the formula says, distance divided by rate. So all we're going to do is look in our chart and put our distance down, 1,800, divided by our rate, which is 4x. Here we put our distance down, which is 300, divided by our x. Distance divided by our rate. So now we have the chart filled in. All we have left to do is to decide what happens with the time. What category does it fit in? Do we have a total time? Do their times differ, or are their times equal? What does it tell you in the problem that says that? Total of 5 hours. That in the problem it has total of 5 hours. If you're writing that down, you might circle it. So what's going to happen is the time of the jet plus the time of the plane is going to be 5 hours. See, since it says the total time is 5 hours, the time of the jet plus the time of the plane is equal to 5. And that's where our equation is going to come. So I'm going to rewrite this up here to solve that. The time of the jet plus the time of the plane is 5. And all we're going to do is take things from our chart. From our chart, the time of the jet is what? What do we have in our chart for the time of the jet? 1800 over 4x plus the time of the plane is 300 over x equals to 5. And we've got to decide how we're going to solve that. And then we can answer whatever question they ask us. So what are we going to need to do? We don't want to have fractions here. All the problems we're going to have today are going to have these messy fractions. So the first thing is going to be to get rid of those. So what are we going to have to multiply by to get rid of them? What do we want to make go away? We want to make the 4x and the x go away. So what could you multiply by?
X times 4x.
Okay, x times 4x, which really is 4x. So we're just going to multiply by 4x. You don't have to use both the x and the 4x. Since x is a part of 4x in the multiplying here, it only takes the 4x to use the common denominator. If somebody decided to use both of them, it would work. You would just get you'll probably get a quadratic equation instead of getting a linear equation and have to throw an answer out at the end. So it's easier if you just use the 4x. So we're going to say 4x times each piece of that. And also, of course, the 4x times the 5, because you've got to multiply both sides by 4x. And I'm writing it down wrong up here. So when we multiply the first one by 4x, we have what left? 1800. When we multiply the second one by 4x, we have left, so to cancel our x's, and 4 times 300 gives us 1200. Nothing cancels here, so we get 20x. Now, when you get to this point, you ask yourself, do I have a linear equation or do I have a quadratic equation? What kind of equation do we have? Linear, because we don't have any squares. All we have are x's. So we can just add these up. That gives us 3,000 equals to 20x. So what's our answer going to be? Divide both sides by 20, and we get 150. Now what we need to do is go back to our chart and see what that x stood for in the chart, and then also see if we answered the question. So we got 150, and let's see, the x is our rate, so we're getting 150 miles per hour, and that's the rate of the plane. So the plane is flying 150 miles per hour. In the question, they ask us to find the rate of the jet plane. In the question, it said, find the rate of the jet plane. So we found the regular plane. What do we do to get the jet plane? Multiply by 4x, because that's the jet. So 4x is 4 times 150, or 600 miles per hour. Okay. So one thing you need to make sure you do when you finish working these word problems is you end up with a lot of information when you finish. You could answer all kinds of questions. You could get the rate of both of them. You could get the time of both of them. So you just have to look and see what they're asking to make sure you've answered the right question.